So yesterday we practiced solving equations using, anybody tell me what two operations we used? What two math operations? Yep.
Adding or subtracting.
Adding or subtracting. So, what two operations do you think we're going to use today? Yeah, Xander?
Multiplication and division.
Multiplication and division. Okay? So, very, very similar to yesterday. We're going to go through the first property. We'll do some examples. Second property, do some examples. And then the last problem is a word problem. Okay? That's usually how we do it. Okay, any idea, what do you think the multiplication property of equality is? What do you think this property allows you to do in an equation?
Multiplying variables.
Multiply, can you be a little more specific? Multiply,
Divide using variables.
anyone else? Multiply what? What are we doing when we're solving equations? You have to multiply where if you're going to multiply? Numbers, yeah, we're going to multiply numbers, but what else do you have to multiply? Like when you do the multiplication, what do you have to be careful about? Or the addition, or the subtraction? What do you mean about the left? What do you mean left and the right?
No left to right.
Oh, no, not left to right. What do you have to be careful when you're solving an equation if you add something? Where do you have to do it? Fred?
Guys, the one we solved yesterday, right? When we had like addition or subtraction. What did we say we added, right? So we did like x minus 9 equals 2. And we did plus 9. What else do we have to do?
Well, where do you do that plus 9? Where?
On each side.
Exactly, on
Yeah.
each side, yes.
That was kind of like.
It's kind of hard to
Yeah,
read
it's
the...
like-
So when
I think
you
you guys all know that I'm the winner, so you're gonna have to explain it too.
so when you do something, whether it's addition, subtraction, or now we're going to look at multiplication, you have to do it on both sides, not just one side. Okay? So the idea here, again, you're not just look at this. Okay, all you're allowed to do is multiply both sides of an equation by the same number.
So guys, have we seen something like this before? Z, have we seen something like this before?
Yeah.
What's on the board, right? What is it kind of like?
The addition and subtraction.
Yeah, the addition and subtraction property of equality. It's the same kind of thing, all right? So it should be kind of familiar to you guys.
Now, why can't you multiply by 0 on both sides? Because I wrote you can multiply by any number except 0. How come? Why? What would happen?
It'd be 0.
Yeah, it would just become 0. If you had something like 3x equals 12, okay, and you said, oh, I'm going to multiply both sides by 0, what would the left side become? 0. And what would the right side become? 0. So you don't want to do that because now you lost all the letters. Okay? You can't multiply both sides by 0. And I think, yeah. All right, so what would you get here if you multiply both sides by 2? What would be on the left, Joe?
The left would be 2 plus x.
Not adding 2, multiply by 2.
Oh, it'd be 2x.
2x. And what about on the right? 6. So what he just told me, 2x plus 6, this equation and this equation are the exact same thing. They're exactly the same thing. They're equivalent. Okay. What would the answer be to this bottom equation?
X equals 3.
X equals 3. What's the answer to the top equation?
2x equals 6. Well, oh,
So the bottom equation, the answer is 3. The top equation, the answer is also 3.
It's already done.
It's already done. So any equations that have the same answer are equivalent. So your goal when you're writing it is you want to get it like this. Okay? All right, let's look at, I think we have an example somewhere. So, oh yeah, so the first thing we're going to do before we look at an example solving, you guys already did this in the warm-up, is a reciprocal.
That's why we did it.
Okay, so if you have a problem, okay, where, let's see if I have an example I can show you, like this. The number in front of y is a fraction. In order to get rid of that fraction, you multiply each side of the equation by the reciprocal. Okay, so that's what you want to know. If you have a variable with a fraction in front of it, to get rid of that fraction, multiply each side by the reciprocal. So just to practice a few more, if you had 5 over 2, what's the reciprocal of 5 over 2?
2 over 5.
2 over 5, yep. How about negative 3 over 4? Yeah, go ahead.
Negative 4 over 3.
Negative 4 over 3.
You guys, the thing is, they're not changing the sign, you're only changing the fraction. If it's negative, it's still going to stay as negative. You're not going to change the sign.
Okay, Nathan, how about 2 divided by a? Yeah, good job. A over 2. And I think we might have one more. Yep, b divided by c. Yep.
C over B.
C over b. Okay, so all you have to do is flip it.
Yeah, even if there's a variable, you can still don't get freaked out because there's a variable with a fraction. Just flip it, that's all. So guys, this is what you're going to need to write on your notes.
All right, so under that first bullet, okay, just like we did yesterday, find the number that's with the variable. Okay, so yesterday it was with the variable and it had a plus or a minus sign. Today it's going to be right next to the variable, or it could be divided as well. So find the number with the variable. Could be a fraction, like in this problem. Maybe it's not a fraction, like in this problem. Okay.
Guys, these ones we're doing, there's not going to be we're not getting into combinations where you're going to do like addition, maybe subtract, and then after that multiply. It's only one step. There'll be one thing on one side of the equal sign with a variable, and there'll be a number on the other side. It's only one step.
So under that bullet, this one we already said. Okay, if you have a fraction next to the variable, just like this, you're going to multiply both sides of the equation by the reciprocal. Yes. Yep. Okay, the next step I'm going to have you write down, but we haven't really talked about it yet. If you can multiply both sides of an equation by any number except 0, you can also divide by anything except 0. So division is going to come up when we do a problem like that. That's going to involve division. Okay, after we do that step, then we simplify both sides of the equation. Okay, simplify what you can. So if you get a fraction like 12 divided by 2, you would want to simplify that. Okay.
So that simplified part means now we identify if we're multiplying or dividing. Now we're just going to basically just do the math to get our answer.
And then the last step is to check if necessary. Again, we're not going to be checking every problem. We said that yesterday, but a couple we'll have you check. So the examples, I think you guys need to write them down. They are not, I don't think they're on your,
An example 1A is to the right of the notes you just took, all the steps and bullets you just wrote down.
like Mr. Wright just said, be careful you don't put it under 1B. That's at the bottom. 1A, what you
1A
just
is to
said.
the right of the notes you just wrote down.
All right. Can somebody read to me what it says on the left-hand side there? Joe?
X divided, it's divided by 4 equals -7.
Yeah, so the left-hand side says x divided by 4. So we've got division. So yesterday we gave you that phrase, you always do the opposite operation. So what's the opposite of dividing by 4? Yeah,
Multiply.
I'm going to multiply by 4. And what else do I have to do? I got to do it to the other side. Now, if I have this, x divided by 4 times 4, what happens there? Xander?
Crosses out.
Yep.
Now you're left, be left with -7 times 4 equals -28.
Yep, exactly. All you're left with is -7 times 4 on the other side, which you said was
-48.
perfect. Okay, so we got our answer. Are we all done?
You don't need to check still.
Right, this problem says to check. So somebody else remind me how we check. Connor, do you remember how to check?
You put the 4 where the X is,
What are you going to put in?
the 4,
So what did we get for an answer?
28,
Careful.
-28.
-28. So we're going to take that and
Put it where the X is.
put it where the x is. Good. So I'm going to put in -28 for x. Copy everything else exactly the same. Okay, so what we're doing is we're hoping when we divide out what's on the left that it works. Okay. Is that going to work? -28 divided by 4? Yeah. If you're not sure, you can just double check it on your calculator. But you get -7 equals -7. We're good. That means that's the right answer. Okay, so any questions on that? So when you see a problem with a fraction and it's just a number in the bottom, that's when you have to multiply on each side. Okay? And I think we've got some more, like as extra problems, right? We'll practice them? Yeah. But I think that's 1B is on the next page. Okay, so as we were going through the notes, I brought this one up and I had you guys look at it. What's different here?
There's a fraction next to the y.
There's a fraction next to the y. It's not like it's y divided by 5 equals 12. The fraction is next to the letter. So what comes up here that didn't come up in the last problem? What are you going to use? We talked about it in the warm-up and we practiced it. The what?
Well, no.
Not division. You're still going to use multiplication.
To get rid of that 2/3, to get rid of that 2 over 3 and just get y. What are
Gemini?
you going to use?
Yeah, exactly. You're going to use the reciprocal. And when you say use it, how am I going to use it? Am I going to add it? No, we don't want to add it. Yeah? We're going to multiply. Multiplied by the reciprocal. Now I need to know what the reciprocal of 2/3 is. What's the reciprocal? Yep, Jenny? 3 over 2. Do it there, and where else? The other side, yep. 3 over 2. 3 in the top, 3 in the bottom. What happens there? Crosses out.
Now put a 6. So you put a 1 at the bottom. So you,
Yep, I could put a 1 at the bottom. Anything else that cancels out on the other side?
you can do how many times is 2 go into 6?
How about on the left side? Let's just finish that up first.
The 2 over 2.
Yeah, the 2's cancel. So all I'm left with is y equals.
That's why we did it, to get the variable by itself with no fraction.
And now, what were you gonna say, Xander?
Just simplify the two, 6 and 2 even more, so how many times 6 going to 2? 3.
Okay, so 6 goes into 2 3 times, and 2 goes into 2 once.
So 9 overall.
It would be 3 times 3, which is 9, over 1 times 1. But do I need to put the denominator? Why not?
Because it's
Well, sometimes if it's a whole number, you still have to put it, but this whole number you don't, because it's a, what's the whole number? In the bottom. It's a 1. Okay, if the denominator is a 1, you don't have to put it.
And guys, any whole number is over 1, we just don't write it every single time.
Yep, everyone's got that. That's important. Sometimes we'll use that trick when we have to multiply or divide.
Guys, for this part right here, when Mr. Hager simplified, let's just take a look at it over here. Is there another way, if I didn't know that like 2 within the 6, like I have a hard time seeing that, is there another way I can do it,
You just
Joe?
go across on how it is and.
Yeah, I can multiply this straight across. All right, so what do I get?
You get 18 over the 2.
18 over 2. Now, someone besides Joe, but Joe, thank you. What does that mean? What math operation, Sophia?
You mean to divide it?
Yeah, 18 divided by 2. When I do that, what am I going to get? 18 divided by 2, guys?
9 over 1.
9. Over 1, which is really 9. So that's enough. You can do it either way. We're not going to mark, if you do it this way, we're not going to take points off. If you do it that way, we're not going to take points off. I don't care. If you can see it and cancel out, that's fine. If you have to do it, I mean, it works either way. Just giving you guys another option.
Yeah. Thank you, Mr. Russ.
I'm not doing right. Yeah, that's good. All right, so now, go with these. So we're using multiplication for these ones. All right, let's look at 1. Oops. So this basically says the same thing, guys. The division property of equality. Divide both sides by the same number. Again, like we talked about before, any number except 0. Right? We don't want to get 0 on both sides. It's going to cancel out our variable. So x equals 8. All right. If I divide it by 2, I'll still get this like we did before. This and this are the same thing. Right? They mean the same exact thing. They're both equivalent. They mean the same thing. All right. So now, for this one, right, with this 3, the 3 and the x right next to it, what math operation does that mean? Mallory, what math operation does that mean with the 3 with the x right next to it? Multiplication, right? Doesn't mean, what did I skip?
Example 2a.
It might just be written wrong.
What is that 2 way?
It says 3a, but
What about the word?
is that the last one, guys?
You skip 2.
Is there 3d? What did I skip?
Oh, wait, what?
You skip 2
I put 1.
and then,
Oh, I put mine on 1.
so could that be 2?
Yeah, let me go back and check.
Could that be 2A and then this?
Let me go down.
Oh, yeah, x equals, x over 2 equals 7.
No, that's just showing that these two are equivalent. 3a, and then I think we have one more. 3d. So guys, they might have just been written wrong on there. So the middle one on the bottom where it says 2a. If you wrote this in the 3a spot, that's fine. You don't have to change it. Just put that, the last one that we'll do, just put it in the other spot. As long as you have them both written down, that's fine. Don't worry so much about what the example number is. All right? So like Mallory just told us, the 3 with the x right next to it means 3 times x. Not plus, not minus, right? 3 times x. Page, what's the first thing I'm going to do?
Right as it's in code, it would be put 1 million for 18 and 3x.
Well, that would be for something like this. right? Because now I have division, I gotta do the opposite of division, which the two examples we did before this, we did multiplication. Now, like Mallory just told us, now we have multiplication. So what am I gonna use?
Division.
Division, right? So what am I gonna divide by?
3.
3. All right, good. Someone tell me, why wouldn't Connor, why wouldn't Paige divide by 18?
Because the 18 would be the number.
It would be a negative number.
Sophia?
Because it's on the side of the x.
Okay, someone explain a little bit more for me. Why would I divide by 3 and not 18, Joe?
You can't take 18 away from 3x because, well,
Well, I could, it would come out as a fraction, I could do it. Gemini?
Because, 3x, you're trying to get the variable.
Okay, I'm trying to get rid of the variable, right? I'm always, a lot of times, guys, this is when we get into the more advanced stuff, a lot of times this is gonna be the last step to solve a multi-step equation. Or when you get into like solving word problems or doing other stuff. This is usually your last step where you have to divide. We're always gonna divide by the number that has the variable attached. That's gonna cancel it out. We wanna get whatever letter or variable we're trying to solve for by itself. So that's gonna give us x. On the other side, Madison, what are we gonna do on the other side?
oh, you're gonna get 6.
6, right? 18 divided by 3 is 6. If you want to rewrite it, x equals 6, that's fine. If you leave it like that, we're okay with that too. Remember, you can always, and we have to check it too, we can always rewrite this too. We can always do 3x equals 18. We can always reverse it so the number's at the end with the equal sign. So it looks a little bit, it looks a little bit neater and something more than we're used to. I think Mr. Hager wants me to check it. All right, so check it. All right, Joe.
So you would,
Tell me what to write.
so you would write 18 equals 3 times 6. Parentheses instead of times.
Oh, okay.
So you do that first.
Gotcha. Parentheses.
Then with the 6.
Yeah. And guys, if you put this is okay too. It's supposed to be a little dark for times. I like this better. It's a little bit neater and you know it's multiplication. But make sure you don't write it like this. Then it looks like 18 equals 36. Put a little something there that separates it so we know. All right, so Mr. Hager put his little question mark to see if it works. All right. What number should I get over here to make it true? 18, right? So I'm going to bring the 18 down. 3 times 6? 18. Yeah, it checks. It works. And again, like I said yesterday, like Mr. Hager and I said yesterday, on the test on Friday, you're not going to have to check every single one. There's maybe only like 2 or 3 you
How
have to
many
check.
questions are on the test?
Please make it 100.
I swear, Joe, I'm gonna slap you if you say that again.
Maybe 12. I think.
really?
Yeah.
Just do 30.
Oh, okay.
Yeah, guys, I test on super long. I test on super long.
I get 5 by that.
Like at most, maybe we'll have 15. But we want to make sure you guys finish during the double block. And I think with the reference sheet, you guys should be fine. Joe?
Can you put extra credit answers on it?
Maybe we'll do an extra credit this week, Mr. Hager, right? Maybe, if you want to, I don't know.
Or
Sometimes what we do, guys, for extra credit is we have you guys go back into we'll give you, say, copy down example 2A from the notes. If you copy it down, just to make sure you guys are keeping your notes and not losing them. You have them all. So we might say write down example from today's lesson, chapter 1, section 1, part 2, write down example 3B. So you write down the whole example and the answer and everything. just to make sure you guys are going back in your notes and you have them. Or if not, if you don't have your notes, you threw them away, then you're going on to Math with Mr. Hager, our website, and looking it up there. It's an easy way to get bonus points. We do that sometimes too, so maybe we'll do one this week.
So this week, remember, we already have extra credit. What's the extra credit I already mentioned?
Oh yeah, right, Mr. Hager.
Yeah. What is it, Connor?
Subscribe to your YouTube channel.
Exactly. If you subscribe to the YouTube, you get 5 points on the test.
Wait, really?
Yes.
How much can I
What is my?
That's what
The Autobody teacher was only throw bags
Oh,
of
yeah.
salt at us.
Yeah. Or
Buddha.
He's awake, see? Alright, let's do,
He threatened to do that tonight.
we'll do this last one, alright?
I annoyed him too much.
It's on the page.
It was good at you.
Alright, so this one, Ginny,
They're Moira.
what are we gonna do? Divide by 5, right? Why am I dividing by 5, Jenny? What does it have with it that tells you have to divide by 5? Has the, not the sign, the variable, good. All right, because it has the variable with it. We always are going to multiply, divide by the number that has the variable. So I divide by 5. Okay, cool. Equals. Mr. Fairbanks, on the left-hand side, on this side, what am I going to have? X, it just cancels out, right? That's why I did it. Fred, on the right-hand side, what am I going to have? Take a second. Not sure. Can someone help Fred out and just tell him, Mallory, can you tell me what this means?
Divide.
Divide, right? So it means 40 divided by 5. Does that make sense now? Okay, give me the answer. That's what I want. What do you get when you do this on this side? Oh, okay. So somebody help out Fred. 40 divided by 5. Gemini. 8. Right? So x equals 8. Now we have to check it. Z-Man. Give me my, help me, I want to write out the expression so I can check it. I want to write out the expression so I can check it. You can do it.
5 times 8 equals 40.
5 times 8 equals 40. Is there something I could put there just so I know that's multiplication?
Right.
Like Joel told us on the last one, right? So I'll put parentheses, oh, my mistake. Put parentheses, 5 times 8 is what, Xander? 40 equals 40, check, I'm good. All right? We're all set. So guys, that's, we're not gonna do a ton of these. We are gonna give you something to practice with. I'm thinking after we practice, I'm thinking after we practice, we'll go over those and then we'll set up our binding. We have one more word problem we have to do. No more questions? Yes, it's homework. We're not done yet. You will get it at some point, I promise. I won't let you leave without it. Mr. Aiden, do you want to do that word problem?
You want me to do this?
Yeah.
Okay, so we've mentioned before, sometimes when you see certain words in math, they mean something. Like sum means what? Yeah? Adding. Difference means subtracting. Does anybody know what the word of means? Like if I said to you to find half of 10. What operation would you do?
10 divided by 5.
Well, you've got half something and then 10. So if you wanted half of 10. Okay, if I said 10 divided by 2, you could do it that way, but how would you do it? Half of 10 times. So the word of means multiply. Okay, so like if I said to you 2/3 of 12, you replace the word of with multiply. Okay, so the word of means multiply. Any questions on that? Okay. So, let's look at this problem. As far as writing it down on your notes, you could put it right at the top. You should have a blank space right at the top of your notes. Just put example 4, put it right up there. All right, so this one says, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his speed. And then they want us to round to the nearest hundredth. How many decimal places is hundredths? 2. So we get around to 2 decimal places. All right, there's a formula we need to do this. Usually the letters they use in the formula are R for rate, T for time, and D for distance.
So time, we'll do time for the 19.3.
Okay, so time is 19.32 seconds. How about the distance?
200.
200 meters, yeah? And the speed, they usually call that the rate. That's what we don't know.
It would be N or R.
So does anybody know what the formula is that you plug these into?
Isn't it?
Yeah, it starts out
D equals T. No, R.
R times T. Yeah. That's the formula you need to use to solve this problem. So if you don't know that formula, make sure you write it down. That's distance, that's rate, or we call it speed, and the last one is time. All right, so what's my distance again?
200 meters.
200 meters. So this guy ran 200 meters. What's the rate?
19. We don't know yet.
We don't know yet, so we're going to leave the rate just as R. And how fast did he run?
19.32.
19.32. Okay, now the goal is to get R by itself. So how would we get R by itself?
You divide 19.32 from each side.
Divide each side by 19.32. 19.32. Okay, so for this, you just have to use your calculator and type it in. 200 divided by 19.32. Now, where should we round that?
10.37.
Yeah, no?
I like 100.
So the 3 and 5, so the second number you're gonna round it up, so it's gonna be 3.6.
So 10 point what?
3.6.
You do it after the third one, so it'd be 10.3.
So it's not 10.36. We don't have to round up here.
Or 2.5.
Because what's the number after the 5?
1
It's a 1. So that means you round the number before
down.
down. You just keep it the same. So 10.34. 10.35. Okay, we just keep it the same. If it was a 5 or higher, then we would round it up to a 6. Okay, so keep it 10.35. Now, what is R again? It's the rate, how fast this guy was running. So what should we put for a label on that? So we're on the right idea. It's something per something, but we didn't use miles in this problem, and we didn't use hours.
Meters per second.
We did meters per second. So if you wanted to get an idea of about how fast that is, anybody know how fast that is? 10 meters a second?
That's
Really fast.
That's pretty fast. Like if you're running at 10 meters per second, a meter is roughly 3 feet, not exactly. So that means if 1 meter is 3, that's over 30 feet. Okay, so that probably means from the front of the back of this room, the guy ran the whole thing in under 1 second from the front of the room to the back of the room.
let's see, he's trying to from here to that thing.
Yeah. So that's over 30 feet per second. That's pretty fast. Of course, keep in mind, he's only doing this for a short time. Okay? And that's an average speed, right? That's average, because when the race starts, how fast is the runner going?
Fast.
Well, right before it, right at the second it starts.
Oh, slow.
Very slow, right? They're not even moving yet. So they probably hit their fastest speed right when they cross the finish line or pretty close to it. So that's just average speed. That includes starting from 0 and then finishing. We don't actually know how fast is his fastest speed. That's just his average. Okay? 10.35 meters per second. Okay, so any questions on that? All right, so a couple reminders before we do the binders. So if you don't have a binder, I think that's what Mr. Roy just left to get. If you haven't signed up for Google Classroom, I think most people did yesterday, make sure you get signed up. First test is on Friday. Don't forget, if you sign up on the website, how many extra points on the test?
5.
5 points.
What's your YouTube channel?
Not the player.
That's the website,
Don't mix it out of it. Don't mix it out of it.
right there.
Can I just
We're
like
talking about-
subscribe to your thing right now?
Yep, if you want to subscribe right now, you can.